Hello, calculus students and seekers of general truths. We've now started out with the basics of the antiderivatives of e to the x and antiderivative of 1 over x, and now we can take a look at some more complicated examples. So here we have a reciprocal function 1 over 5x plus 1. So it's a little bit different than just simply 1 over x. One very quick reminder, the antiderivative of 1 over x is equal to the natural log of the absolute value of x plus a constant. And this is very similar to that, but we're going to use substitution here in this case. So we can say that u is equal to 5x plus 1, right? So du dx will be equal to 5. And then dx will actually be equal to 1/5 du, okay? So with that very quick process of substitution, we can set up our antiderivative as follows. The antiderivative of 1 over, instead of 5x plus 1, we can have u, and instead of dx, we can have du and 1/5, and I can pull the 1/5 out to the front because the constant multipliers don't really make much of a difference. So this is equal to 1/5 times the natural log of the absolute value of u plus a constant. Then finally, my last step, we substitute back 1/5 times the natural log of the absolute value of 5x plus 1. Okay? And remember, in this case, the integration by substitution, we're using what's known as the chain rule and going in the reverse direction. All right, so the next example, the antiderivative of e to the 8x. I think you've done this many times already, but very quick practice. This is u equals 8x. Du dx is equal to 8. Therefore, du over 8, or 1/8 of du, is equal to dx. We can replace, right? So this is going to be e to the 8x, but that's just u. Instead of dx, we have 1/8 du. We can pull the 1/8 out to the front, and our final answer is 1/8 e to the u, because remember, the antiderivative of e to the x dx is itself plus a constant. Okay. And substituting back, we get 1 over 8 e to the u, but u was 8x plus a constant. All right, there you have it. Some quick examples of more complicated scenarios. Next couple videos, we're going to take a look at some cases where the base may not be e, or we might be using the log of some other number.